Okay, so I guess we're reaching the end of our workflow here. We just need to make a few more changes. All right, let's move from this sort of intermediate step to a real workflow. Here's what we want to do. We want to take our code and our data. We want to put it in Scratch. We want to run our job there. And when we run our job there, we want to run it on all our files. Okay, and so we want to sort of run all our files simultaneously or concurrently, analyze each one of our files, not one by one, but simultaneously. Okay, so that's what we want to do. And then once we're done, we want to move our files back from Scratch to our home directory, and then we want to bring our plots back to our local machines so that we can have a look at them. So the first thing you want to learn to do is to submit a job, or rather submit several jobs at once. Rather than, one way we can do this is create several submit scripts, submit1.sh, submit2.sh, and all the way up to submit17.sh. And that would correspond to Nelly creating 10,000 submit scripts and then submit each one of those. Okay, and that doesn't make any sense. We're going to use a feature of the scheduler called a job array. Okay, and hopefully I won't mess this up. But there's a small example of how to submit a job array, and I'm gonna put it up on the Etherpad. Well, actually, there's actually a nice repository of several kinds of jobs that you might want to submit, and I'm going to stick a link to it here on line 75. All right. The kind of example, and for example, there is an example of how you might want to run an MPI program here. But the one that we're interested in running is a job array. And here's what the submit script for a job array looks like. You can ignore everything after line 9, but let me just explain what's happening here. As before, we have to specify the name of our job, some resources, and here we're selecting the wall time on a different line, but we might as well append the wall time here. This special option J. All it does is, remember that every time our job completes, we get two files. One that ends with O dot something, dot O something, and the other one that ends with dot E something. And all this does is it puts them both together in a single file. So it joins the output and error files into a single file, dot O something. But here's a special option we're using here. We're creating a job array with indices 1 up to 8. Okay, and all that does is that it launches not one job but 8 jobs, and each of those jobs is going to have a different value for this special variable PBS array index. Okay, so for the first job, this variable will have the value 1. For the second job, this variable will have the value 2, and for the third job, this variable will have the value 3, and so on and so forth. Okay, that's all that's going to be different in all of these jobs. Now, what these jobs do doesn't matter, but you have to know that you can specify a numerical range using J, and when you launch this job, you're actually launching 8 jobs, and each of those jobs is going to have this PBS array index with a different number. So here's a suggestion that I'll make on how to split the work up here. And maybe it's not the best suggestion, but this is the best we can do with the naming scheme we have here. You'll notice that the names of our input files all look like NENE. 017 something, or 018 something, or 019 something, or 020 something. So let's split our big job up into 4 jobs, or 4 separate jobs. The first job will take care of all the files that begin with 017, The second job will take care of all the files that begin with 018. The third job will take care of all the files that begin with 019. And the fourth job will take care of all the files that begin with 020. So the range of our PBS array is going to just extend from 17 to 19. Okay, so that's the strategy we'll use here, or rather 17 to 20. And so what's if each file takes about a minute to analyze, how long will we have to wait for all our files to get analyzed? (17 minutes? Is that right? No. So all the files that begin with 17, there's 5 of them, so that'll take 5 minutes. Concurrently, all the jobs that begin with 18 are going to execute, and that'll take 3 minutes. This one will take another 3 minutes, and the jobs that begin with 020 will take 5 minutes. But remember that these jobs, although there's 4 of them, they're all going to be executing concurrently. Okay, so I guess we'll have to wait about 5 minutes for all these jobs to execute. And that really has to do with our poor naming scheme for our files. Okay, if our files were called input1.txt, input2.txt, input3.txt, all the way up to input17.txt, we could actually break up our job into 17 independent pieces, submit them all at once, and wait just 1 minute for all our jobs to execute. Okay, but right now we're stuck with this naming scheme. Of course, we could rename our files, but for now, let's just go ahead and split our job up into 4 chunks. So let's go ahead and do that. The first thing we'll do, though, is we'll copy all of our data to something in Scratch. So I want to make a directory in Scratch. Am I going to use Scratch 1 or Scratch 2? Scratch 2, exactly. And I'm within Scratch 2. I have my own directory, and here I'm just going to create a directory called Nelly. That doesn't do anything, it just creates that directory. One thing I'll do is I'll copy over all my input files to Nelly, to Scratch 2. Can everyone read this? No problem. I seem to have frozen here. And I'll also go ahead and copy stats.py to Scratch to username. Within Nelly, I have to create 2 other directories. Can someone tell me what those are? Sorry, what? Results and plot. Because stats.py is going to expect those directories to exist, and if they don't, it's going to complain. So I'll go ahead and create those as well. So make dir scratch2 /username/results, and make plots. All right. So that's a handful of commands. Let me just give everyone at least 2 minutes to copy those onto their screens. Okay, any questions about any of these commands? Yeah.